Hello and welcome to part 2 of inline template functions. So last video I showed you how dynamically via template argument compare two things and also inline them. So today we are going to concatenate inline functions and also have this function then be inlined. So we are going to use recursive types. So let's show you what I mean with a quick example. So we have here class mul, and then with template arguments we'll put in a bunch of integers. So int current, int ... others, and here is static int out const. So it's you can change this, change it, and then we say here current multiplied by mul, and as a template argument we will take others. And then here we need to have a specialized type. So a template argument will also have something named current, and we put it at this position of current. And here I forgot to get out here, and static constant out equal current. And yeah, let's test this. So mul 1 2 3 4 out. I always forget public. It's really annoying. Anyways. Yeah, so the result is 6 as expected. 1 times 2 times 3 is 6. And yeah, so let's get started. So we will have a class named cut_funcs, and just make something like that. So this is actually just like a helper class. Yeah, but we'll see in a moment why. So as before here, can actually just copy it, paste it in there, and maybe we will just have one argument here, float x, and as template argument we'll have a bunch of functions. So we say current class others, and we will return the inline function of the current. So maybe we'll just write a really simple inline function. So again, something like class mul, and then or maybe mul x, and then we have template int k, and then we again have these inline function. So like with these things, it's actually kind of important to have this false inline, because yeah, like there was one situation where I wanted stuff to be inline, but it wasn't inline and was slow, and so make sure you have false inline here when we're doing stuff like that. And then here we'll say x times k. So it's actually like just multiplying x by a constant. So this is a really good toy example. So this is why we're using it. And yeah. So current Then go into the namespace of current. So this will be mul x with template argument k, and we will call the inline function. And then what we will do is we will go into the namespace of cat funcs others, and then also call inline func. So this will be calling this one, or later on when we have our recursion anchor implemented, this will call inline function there. And then x. Okay, let's copy and paste this. So this is now our recursion anchor. So we are actually going to use just an empty class, does nothing, like really literally does nothing. This is stop inline. So later on, when we can just wrap something around it, so we don't have to use it. Yeah, it comes clear in a moment. So stop inline here, and basically what we are doing here is just this is an identity function. Yeah, so yeah, let's test this out. So it actually should work right now. So so when we have here cat funcs, so current, so that's the first one, then we'll iterate over these template arguments and call inline func. So first the first one, then the second one, on and on. So can write here mul x 2 mul x 3, go into the namespace, call inline func, and then with 1, and that should also be 6. So let's, yeah, it's I, of course. I forget it every time. Yeah, it's actually really completely normal to have this amount of errors occur. So it doesn't mean we did something completely wrong. It just means somewhere is something missing. Okay. Yeah. Wrong number of arguments. Template argument 0 should be at least 1. Ah yeah, stop inline. We forgot stop inline. And now it works. And yeah, 6. So as expected. So this looks a little bit ugly with the stop inline, but we can fix this really easily by just simply saying something like cat funcs. Class cat funcs public, and then copy paste this, and here we say just template arguments others, and then pass this into our cat funcs. Yeah, so we can actually just copy this, paste this in there, and then we say comma stop inline, and then we don't need it anymore. So this is why I make this weird underscore, so we know, okay, hey, it's just an helper class. And now if I don't forget anything, it will compile. Yeah, so yeah, so that's for this video. Like next video I will show you how actually like to have multiple inputs, just not only in X but also like a beta or an alpha or whatever you want in your function to have. So yeah, it's yeah, see you.